Hi everyone, my name is Amanda Hutter. The presentation I'll be giving you today is titled Braiding Knowledge, Environmental Communications of Farmers and Anishinaabe Using Drones, Data, and Deep Communication. A quick acknowledgement before we begin. In my title, I have identified this work is for farmers and Anishinaabe, which is the word used for First Nations or Indigenous by preference of Anishinaabe themselves. These two groups came up purely by chance, and I am ultimately thankful to both. This work is, however, for anyone. More specifically, it is for anyone who is aiming to help protect or restore land, which is the goal that inspired this research. For myself, from the land in Saugeen Ojibwe Nation, Saganan, for its lessons, as well as for my two groups of friends identified that work to protect their land in Anishinaabe Nation, where this research took place. Thank you. Today, this is where we are going. I'm going to teach you all about our work in creating what is called the D3 process, which stands for Drones, Data, and Deep Communication. The D3 process is just that. It's a process. It's a communication process, one that has been created specifically for environmental communication. In this process, knowledge is woven together to create communication materials, some of which you can see in the bottom left corner there. So keep this picture in your head as I walk you through what went into creating this process and why it looks the way it does. Our agenda today is fairly simple. I will go over a bit of background, then we will get into methodology, including the design of research, results, and finally conclusions, with a few examples along the way. The creation of this process was in response to the very unique communication needs that both farmers and Anishinaabe in our use cases had regarding their land, both from Northern Ontario, also known as Anishinaabe Nation. Our first use case was the Black River Farmer Co-op, who needed help in management planning across their cooperative farming structure set up for sustainable farming. Our second use case was Matachewan First Nation, who needed a way to help improve communication processes that would be included as part of the custom engagement approach to forest management planning that they were working on with the Ministry of Natural Resources and Forestry. In both cases, protecting and restoring ecosystem services and their land was a struggle resulting from communication. Drones can be used to communicate just about anything you can dream up about our environments. The acronyms of the drone world are too many to list and continuously change, so I use the word drone to represent the vehicle itself, and unoccupied aerial systems, UAS, the system part of which includes the sensors, GPS, remote controls, etc. that help the drone to fly. It's a piece of information communications technology that delivers mainly visual communications materials, such as maps or pictures. The data collected by a drone is often integrated with spatial information, photogrammetry software, machine learning. These layers are then combined, often using geographic information systems. All of this is what makes drones so popular today. They are incredibly flexible. However, despite such a huge range of applications, a huge number of communities of practice, like in agriculture, mining, forestry, etc., thousands of techniques for data capture and processing, there are sweet few examples, maybe a handful at best, of applications where the expertise of tacit knowledge holders themselves direct the flight, analysis, or communication planning behind the use of drones. The communication needs of land stewards are equally as varied. The reason for this that I base my assumption on is that every single person has a very different relationship to ecosystem services, the ways that we benefit from our ecosystems. We all use our environments in different ways, connecting these relationships to restoration or protection, for example, through securing funding, or to manage land better, maybe using better information about impacts to environments, or to address land conflicts by validating the expertise of Anishinaabe. These are environmental communications, and each need is unique and oftentimes very difficult to communicate. In addressing these unique communication needs, it was found that this research actually filled some more gaps. For free and prior informed consent, FPIC, consultation obligations for development in Indigenous territories, there does not yet exist a structured approach for operationalizing the principles of this approach. For participatory geographic information systems, PGIS techniques, the visualization of land values using drones has large potential to improve the maps that are used alone with this technique. Looking at the processing and structural requirements of this proposed process lends itself to Spatial Decision Support Systems, or SDSS, software, specifically the development of integrated software which focuses on tacit knowledge holders as users and integrates user-defined environmental communication needs, flight planning, and analysis processing, something which is largely non-existent for tacit knowledge holders. Our research then turned into a goal: to explore the design of a process and framework that uses drones to create communication materials for environmental restoration and protection. This process was to enable the creation of user-defined ecosystem service-based communication materials that would address the unique communication needs of its participants, tacit knowledge holders, which is the word for the multi-generational and experiential form of expertise of our farmers and Anishinaabe. The meat of this process was to figure out a way to employ the use of any number of unoccupied aerial system tools to communicate the relationships that tacit knowledge holding land stewards had with their ecosystems. So the goal was simple: to go from point A to point B. Since this work was largely exploratory, research occurred in 3 stages, which honestly seemed to never end. Combined, the steps in these stages would fulfill 3 objectives. The first was to explore appropriate methods and tools that could be aggregated into a process. The second was to test out the steps laid out for this process through action research methods, more or less translating what's on paper into real life just by talking to people in interviews, teaching in workshops, collecting feedback on pictures using photo elicitation, etc. And the third was to then finalize the design of the actual process based on the results from testing. You can see red circles in this figure, and these are where the primary data was collected through participating with people during stage 1 and 2. So knowledge mobilization played heavily into this research. There was a bit of organizing to do before data collection. Since the end goal of this process was to create communication materials using UAS tools, I needed a way to sort through quite a volume of these tools. So I defined them as all tools, technology, software, basically anything that would support the creation of communication materials in this process. So I used 3 principles for narrowing UAS tools down: relevance, so excluding things that weren't relevant, like warfare applications or info on honeybee drones; reliability, so asking things like, is this technique tested and proven? And reasonability, so looking at things like cost, ease of access, capacity required, etc. That got me through UAS tools. Looking specifically about applications, I was able to identify 3 types of communication materials that were found throughout the tens of thousands of different examples of applied drone work. The first, simple visual imagery, so pictures and videos. The second was general analytics, aka click of a button communications, where there's already existing software for processing of imagery, unfortunately oftentimes at a cost. The third and the most glorious category is advanced analytics, where data collection and processing requires machine learning, algorithms or algorithm development, or sensors that require specific software for processing, like LiDAR. These were all turned into a teaching video used in stage 1 of research. For organizing the base of the process in stage 1, there were actually 9 different tools used to give structure to the process itself, but I want to focus on 2 main ones. I used Grimm et al.'s standard protocols for agent-based modeling, typically used in GIS applications and neatly called the ODD process, for overview, design concepts, and details. The ODD process would help my own process to extract information from interviews conducted during research steps and place them into 3 categories that much of the D3 process was based on: flight, analysis, and communications planning. The second was a framework developed by the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, IPBES, for translating diverse worldviews on ecosystem services into science policy platforms. This IPBES NCP process, as it is called, formed the base of our own framework and thus alerted me to an unexpected emergent result of this research. And that was just how incredibly much I detest acronyms. But moving on to the real results. As an overview, the main result was a 3-phase process organized into steps for creating communication materials using a drone. The first phase involved, before anything else, relationship building. This was followed by the first step in the process, which was an introductory video showing those 3 types of drone applications that we just talked about. That was followed by an in-depth planning interview process that was divided into 7 sections and was intentionally designed to have participants inform as much of the communication creation process as possible just by telling stories about their land. Interviews were then analyzed using in vivo, using 43 different nodes to categorize information into, combined with appropriate techniques from literature. Then the information provided by both participants, the technology steward, myself, and literature were all organized into an Excel chart template that was created in stage 1 of research. This chart, at this point, contained all information needed for flight planning, analysis planning, and communications planning required for creating each communication material that was identified through participant interviews. This, I lovingly made my own acronym for and called it the FAC Plan, FAC. The FAC Plan was basically like a cookbook of recipes that each use case could use to themselves create or collaborate in creating their own communication materials. This FAC Plan was presented to participants and feedback was collected. This feedback was used for a step in the proposed Phase 2 process during a workshop to greater build capacity and fine-tune communication materials. Unfortunately, also proposed for the second phase of the actual process was all UAV flights and the actual creation of communication materials, which this research was not able to fully complete due to delays in ethics approvals. The collaborative workshop was, however, tested as planned, and which was also where our participants in one use case announced their preference for calling this process a tool for fighting back. Altogether, for use case A, using this process, a total of 27 very different possible communication materials were identified, covering over 18 different ecosystem services. You can look at some here. In use case B, Matachewan First Nation, a total of 19 different communication materials were identified across over 22 different ecosystem services. Now I say over this number of ecosystem services because not all were able to be addressed while I was figuring out how to organize interviews into communication materials. Now granted, each one of these communication materials could likely warrant its own individual thesis, but I made that very easy for future researchers. Just grab a copy of the FAC Plan template and you more or less have some basic instructions on how to go about it. During the third stage of research, the process found its name from the helpful suggestion of Miss Helen Hambley, who ingeniously combined and categorized all of the elements within this process into what is now known as the D3 process for its use of drones, data, and deep communications. If you want a good story, ask her about the 3D type D3 schematic I drew up to try and visualize the D3 process into a framework. This one, believe it or not, it was a little easier to grasp. This is the framework that the process is attached to, not surprisingly called the D3 framework. Basically, everything involved in the process was just laid into a starburst shape, the center showing the phases, the next ring outwards showing the IPBES focus, the next ring outwards showing the steps used to achieve the goals of the IPBES process while creating communication materials, and the last outside ring showing the associated interdisciplinary tasks, techniques, tools, so any of these rings can be added to over time as more work is done on the framework. With all of this behind us, this process provides a realistic way to help land stewards communicate better about their relationships with ecosystem services. In its structure, UAS tools and techniques are carefully woven together with the expertise of land stewards, geotechnicians, and technologists. During the testing of the process, it was able to build the capacity of participants for telling their own story of their relationship with ecosystem services. Following testing, proposed in the FAC Plan are customized communication materials that are able to be made by, with, and for our participants that they can use to make better decisions about land management or provide valuable insights back to their stakeholders. It's a process. It's the D3 process. In conclusion, the biggest possible picture painted by this work is to show just how much is still being missed in communications surrounding conservation and agriculture. If we are aiming to feed, house, and provide for 9 billion people someday, then other knowledge systems, including the expertise of farmers themselves and the traditional knowledge of Indigenous peoples, must be given the space to be expressed, the opportunity to overcome limitations, and validation of its usefulness in its ability to protect and restore the services that our ecosystems provide. The steps outlined in this process are easily able to be added and combined with participatory GIS methods. The many tools incorporated into the process, including flight, analysis, and communications planning, with some help, these can be integrated together into spatial decision support system software for use by tacit knowledge holders. Finally, throughout this research, we have found a great way to operationalize the idea of co-creation of knowledge without sacrificing authenticity or respect for different knowledge systems using a very simple concept, the braid. For processes of free and prior informed consent, this is exactly what is being requested, both within literature and in real life. And that, as they say, is that. Thank you.